Hi everyone, and welcome to this week's Tech Tip. Today we're going to take a look at cutbacks and extensions and how they work within Onyx. Cutbacks are used to define where certain members extend to and where they terminate when meeting other members at an intersection. We have a dedicated menu for cutbacks and extensions which can be found within our panel properties. In the miscellaneous tab, where you'll find we have our cutbacks menu and our extensions menu. So we have various methods of controlling where certain members extend to and where they stop within our panel. So you can see we have options for headers, sills, verticals, amongst some others as well. The position of members and how they extend and intersect is very important not only in MWF but also within Onyx. If your members aren't intersecting correctly, you'll find that things may not show as expected. So let's jump into Onyx just to show you what I mean. So here within Onyx, you'll see that we have two panels, panel 1 and panel 2, which are the same panels that we have inside of our Revit project. So I'm just going to load in panel 1. And once loaded, you'll notice that majority of our members have operations that have automatically been placed. So for our cripple members, you'll see that we have this dimple operation as well as a lip notch in this case. For the cripple member to the right, you'll notice that there are no dimples or lip notches placed for this member. And this has all been controlled based on the connection between the two members and how they're intersecting in MWF. So if I go back into my MWF project to panel 1, you'll see that when we focus on the cripple members above our bearing header, that this particular cripple isn't intersecting our bearing beam top track. To show this more clearly, I'm going to set the detail level to coarse, where you'll see the location lines associated with each member. For our cripple member here, you'll notice that it doesn't overlap with our bearing beam top track, and this is why there is no operation placed within Onyx. We can control how these members overlap using cutbacks and extensions where necessary. You'll see for panel 2, all of our cripples are overlapping our bearing members and also our sill members at the bottom. Adjusting the panel cutbacks is very easy to do, and if I go into the panel properties, I'll just show you how we can adjust these cripple members. So you can see we have various options for different member types, but if I wanted to focus on the intersecting cripples, you can see we're currently extending those members to the outer side of the track, but I want to focus on the inner side in this case. We have other options available as well, but this is just to demonstrate how the tool works. So as you zoom in here, you can see that these cripple members are now cut back to the top of the member, and you'll see the location line also reflects this as well. In this case, we do want to have the cripple members overlap the bearing beam top track, so I'm going to make an adjustment to just set those back to their previous state. So in Onyx, if I load in panel 2, you'll see that all the operations are placed as expected. So another thing which will determine which type of operation is placed for your members is whether the member is a track or a stud member. So in this case, we have a stud to stud connection, which means we have a lip notch operation along with a dimple. In panel 1, we have track members which are intersecting stud members, so a stud to track connection. And you'll notice at the top of this, or where the connection is placed, you can see we have a swage and a dimple in this case. So if we have a track to stud connection, we'll expect to see a swage and a dimple, and if it's a stud to stud connection, we'll have a lip notch and a dimple. Within our panel 2, you'll notice we have these diagonal members, and if we just zoom in on those members and change to a coarse level of detail, you'll see that the members aren't fully intersecting this vertical, so our diagonal members aren't fully intersecting the vertical member. This means inside of Onyx, there won't be an operation visible for these members where they should be connected. So back into panel 2, you'll see that we don't have any operations placed where these members should be connected. So if I change the view to transparent, you'll see this more clearly. To rectify this, we have a tool called extensions, which we can use to extend any of these diagonal members. So if I go to MWF, into the panel properties, miscellaneous, we have extensions. If I click edit, we can then enable extensions and set the maximum angle and also the extension length. So what I want to do is extend this by 1/2 inch. You can see this is the original length of the member, and this question mark and dimension represent the extension that we're going to add. So I'll click OK, and then you'll see that we have extended the members so they're now intersecting that vertical member. All that's left to do now is to upload the panel to Onyx. So I'm going to say upload panels. And now when we go into Onyx, we can just simply load in panel 2. You'll see that we have our operations and dimples placed based on the intersecting members now in the right locations. So that was cutbacks and extensions and how they work within Onyx and also how they work within MWF. I hope you enjoyed the video. Thanks for watching. Have a great day.